Okay, so let's work some extra mixed problems. These are from your stuff that's due on the day of the test, right? I want to see this either on hard copy or you can have it on your iPads, and I'll walk around the room while testing starts and check off either the hard copy or the iPad version. But this needs to be ready tomorrow morning. Test day. Yay. They're doing the wave. Oh, it actually worked. That was good. 4 out of 28 woven. All right. I teach English. I teach chemistry, not English, obviously. Solutions of sodium fluoride. What do I write? Anybody? How about F minus? And dilute hydrochloric acid. What do I write? Can you kind of see what's happening? Do I need the Cl? Really don't, because look, I'm making a weak acid, so that was a double replacement reaction. Okay? And that's balanced. Would the resulting solution conduct electricity? That's a good question, Ms. DiMartino. Demo. HF, what is HF? Thanks, it is, but what is hydrofluoric acid? It's a weak acid, so will it conduct electricity? Think about the day we did that electrolyte stuff. Isn't there, I'm throwing things at you. Yes, isn't there sodium and chloride ions in the solution? So it would be, yes, due to the spectator ions. Those things are causing that to happen. Okay, next, aluminum metal. So what do I write? Al, no charge, is added to a solution of copper 2 chloride, so I can write both of them. Can I make this a double replacement? No, because there's not anything to double swap. I could do a single replacement. Is this a single replacement? Going to metals first, can I make something go up and something go down? Aluminum goes to 3 plus. Copper goes to 0. I can take it to 1, but it actually goes to 0. Looking at now, my common factor of electrons has to be 6, so copper needs to be multiplied by the 3, and aluminum by 2, and then we get a balanced equation. What color changes will be observed? Copper 2 and aluminum together, what color is that solution? Blue from the copper 2 going to silver, really? No. Aluminum ions in solution are colorless. Colorless. Aluminum solid, yeah, that's silver. But remember, these are dissolved ions. Think back to the lab we did where you dissolved the magnesium and you did the single replacement kicking the copper out. The copper was a red solid, right? But the thing you filtered for the most part was what color? Colorless, because that was zinc 2 ions, so that's going to be similar to this. Okay. Yeah, we'll get to that. There is a rule that if you are diamagnetic, meaning all your electrons are paired up, you're colorless. If you have unpaired electrons, it's a colored solution. But we'll talk about that more. Right now, just focus on the basic ones that you've had practice problems with. Water is added to a sample of pure sodium hydride. It doesn't say anything, but since it says we're adding water, to me that's a safe enough assumption that this is solid. So what does a hydride in water make? Reminds me of a push-up problem. Hydrogen gas, and that base is split up because it's strong. So we have 3 H's, 3 H's, 1 Na, 1 A, 1 O, 1 O, and it's good. Describe a test to positively identify the gaseous product. What would we do? What thing? Glowing splint, and what would it do? No, it wouldn't go out. It would pop, or remember that it goes what? Remember that sound? I know y'all did it. Sounds like you stepped on a chihuahua. Pop or bark. Sure. What? Am I going to take points off of that? No. You're more than welcome to, but I finished the test first. Don't be like, I ran out of time because I was drawing the chihuahua. That would not be an acceptable use of time. Ethanol is completely burned in air. So, yikes. Ethanol has how many carbons in it? 2 carbons. So it's C2H. Instead of there being all 6 H's, there's going to be 5, and the last one's going to be replaced with an OH. That's ethanol. Completely burned in air. Smack, smack. We get the same typical 2 products we always get, which is carbon dioxide and water. And then to balance this, 3. Let's double the ethanol. I need 2, but wait, we have an odd, 6. So a 3 there and a 2 there. 3 there. 6, 7, 7, 6, and so on to record that. I was just asked if it would be okay to write ethanol as C2H6O. That is not an acceptable version because that leads to the belief that it could be an aldehyde where the O is double bonded to the last C as opposed to the OH being a complex to make a hydroxide group. So it's part of the standard format that the OH has to be written together. Is a reaction endothermic or exothermic? Just by common sense. It is what kind of reaction? Combustion. What does combustion reactions do? Blows up. So it's exothermic. Good. You know, these are the type of questions you might not have seen that before, but you know enough to kind of figure that out. A strip of copper. Oh, this is ugly. This is the ugly one. UGLY. You ain't got no alibi. You're ugly. Yeah, yeah. All right. Copper is immersed in. This is the one time that we keep in that nitrate because it's part of the redox reaction. Okay. Looking at this, we're going to look at that polyatomic, and it is going to decompose to what gas? Because it says dilute nitric acid, NO. Now, why am I doing redox? People are asking, I'm sure. You can't, there's nothing to double replace here. It's a single replacement, so it's got to be redox. Okay. Specifically, nitric acid with what we call a coinage metal is going to do this. So it gives off nitrous oxide. I should show you, when you put a piece of copper metal in nitric acid, you get this orangey gas, and you're going to be doing a lab with that. It's a really cool lab. It's a copper to copper lab, and you're going to see this reaction in action. So that makes NO. So what happened to the N's oxidation state? It went from a +5 to a +2. So that went down. What can I make go up? Copper can then go to +2. And then what should I do? Add some agua. And we're not going to waste the time right now, but it is all balanced on your answer key online. I don't want to deal with it. What happens to the pH of the solution as this reaction proceeds? Increases. Good, because the H plus is used up. The nitric acid's used up, basically. Okay? A solution of sulfuric acid, so what do I write down? That's a strong acid. H plus SO4 minus 2 is added to a solution of barium hydroxide, Ba plus 2 plus OH minus, until the same number of moles have been added. What is the H transfer going to be? What are we going to make? Water. Okay? And since they're both strong, did we need the barium and the sulfate? Nope. Ta-da! Ta-da-ta-da! Retraction. Sol can bag hags pretty badly. Demo had a brain fart. Retraction, retraction. I hate when I have retractions on tape. All right, there we go. Much better. Calculate the volume of 1.0 molar sulfuric acid. So we actually need to make sure this is balanced before we do this. 1 barium, 1 sulfate, and 1 water. So that looks totally balanced. Calculate, is it balanced? Yeah, it's balanced. So we have 1 molar sulfuric acid, so we have 1 mole per liter. And we want to calculate the volume of this. So we want the volume required to react entirely with, hold on, I can't read it, let me move it over, 100 mils of 0.5 molar barium hydroxide. So this is, we need the same number of moles then for it to react, because it said equimolar. Any ideas? This is my known. So what do? Find moles. So somebody with your calculators, multiply 0.1 liters times 0.5 moles. You don't need your calculator for that, and that is 0.05 moles. So that means for 1-to-1 mole ratio, because 1-to-1 that's balanced, we need then 0.05 moles of this. The question is moles per liter. What volume do we need to react with 1 molar? So what's 0.05 divided by 1? So 0.05 divided by 1 is the same thing, silly. 0.05 divided by 1 is 0.05. So gosh, so we need, golly, 0.05 liters or 50 mils. Got it? I had a good question asking if you could use M1V1 equals M2V2, meaning a dilution. You can only do it in this case because the mole ratio of the sulfuric acid to the barium hydroxide is 1-to-1. If it's not 1-to-1, you have to find moles, mole bridge, and then from there find what you're looking for. So better safe not to use M1V1 unless it's truly a dilution problem where you're making a stock and you're making a diluted product from that.